Hey dear subscribers, welcome back to the channel and today we are going to discuss the conceptual questions which are based on this chapter 9 forces and laws of motion. Stay tuned to the channel because next channel we're going to this next lecture we are going to discuss everything, every numerical which is important, which is based on this chapter 9. So without wasting any time, let's get started today. But before that, don't forget to subscribe on the channel. Thank you. Let's get started. Okay, the first question is, and it's in the form of a MCQ. So question is, which force, balanced or unbalanced, can change the state of the body? And we have four options: balanced forces, unbalanced forces, both A and B, neither A nor B. See, what happens is, whenever you have a MCQ with you, either the moment you read the question, if your all the concepts are clear, you know the answer without even reading the option. First. Second thing, sometime by the question, we may not get the answer. So we have to go through four options. Even after reading the question, as well as going through all the four options, if you're not sure about the answer, then in that particular scenario, ruling out method always helps. What does that mean? You have to keep on ruling it out. कि ये option तो it's absolutely not possible. This option is also not possible. So once you go in the reverse manner, you'll be left with the only one option that is going to be the answer for your particular question. So that is one of the ways in which you can solve the MCQ. Okay, so see, the MCQs are very easy. Why? Because answer is there in right in front of you in the options of in the manner of the four options available. उसमें से ही answer होगा एक, right? There will be nothing which is outside of this four option. तो आंसर तो है आपके सामने. Now, if your concepts are clear, you'll be able to answer. If not, then you'll have to apply this theory of ruling out. Okay, it really helps. Now coming back to this question, so which force helps? So for that, let us see an example. So this is an example in which there are two people. So there are two people who are in a claw fight, right? So they both are they are playing this game of claw fight. So see, both are applying force on each other. So here in this case, this person, the person 1, let us name this as person 1, is applying a force of 3 Newton on person 2. And in return, the person 2 is applying a force of 6 Newton on person 1. So we've seen that whoever applies a greater force is able to push the claw of the other person down. Right? So this person is applying a greater force of 6 Newton and this person applying a force of 3 Newton. So there will be a resultant force of 3 Newton in the direction of the greater force, right? So are these forces balanced or unbalanced? Of course they are unbalanced. So that means if there are unbalanced force, so ये state तो change हो रहा है object का. Right? Let us consider one more example in which there is a tug of war and both the person are pulling the rope with the same force. That means balanced forces are acting. So if balanced forces act, this rope doesn't move. So by seeing this two example, we are clear that whenever there are balanced force, the body का state change नहीं हो सकता. If it is in motion, will be in motion. If it is red, will be at rest. But if they are unbalanced, then there will be a change in the state of the body. So what is the answer for this one? Unbalanced forces can change the state of the body. So the correct option is B, unbalanced forces. Right? Moving on to question number 2. Question number 2 says that a linear object is at rest. Its linear momentum will be. And there are four options: 0, small, large, can't say. Okay. Now object is at rest. See, if object rest पे, then that means there is no velocity in the object. So what will be the linear momentum? See, momentum मतलब क्या होता है? It's mass as well as velocity. So दो अगर object का mass ज़्यादा हो या कम, अगर they are at rest, then linear momentum is going to be 0. Why? Because momentum is the product of mass and velocity. So both of the factors are very important when you define momentum, right? Mass as well as velocity. So अगर question ऐसा भी है कि heavy object, so mass ज़्यादा है, that doesn't mean कि momentum would be large. Are you getting me? Ki what is the confusion trick here with the heavy object? So by looking at heavy, we might think the momentum would be large. But there is another thing associated, which is that the object is at rest. So momentum is a product of mass and velocity. So we have to see both the mass and the velocity. So if it is at rest, then the momentum is going to be 0. So answer is 0. What if the question would be like this? A heavy object is moving with a large velocity. Now mass bhi zyada hai, velocity bhi zyada hai. So then its momentum would be large. In that case, the answer would be large. So don't get confused between what is linear momentum and momentum. Both are the same thing. Linear word, whenever we add to any particular object, then that means we are talking that the object is in line. That's it and nothing else. So don't get confused. So momentum is mass and velocity. Hence it is going to be 0 because velocity here is 0. So our answer is A, 0. We're moving to the third question, which is which of these is not a vector quantity? Vector matlab the one which has direction as well as magnitude. So now let us see which of these doesn't is not a vector quantity. Option is mass, velocity, momentum, and force. See, the moment you read the question, you have the options here. You know the answer. कि वहाँ velocity is तो speed with direction. So इसमें तो direction ही होता है. So it's a vector quantity. And momentum is a product of mass and velocity. Velocity is vector. So momentum is out to be vector. Force is mass and acceleration. So if it is acceleration, acceleration is always in a direction. So that means mass, which is a characteristic property of a body, is not defined by its direction and hence it is a scalar quantity. It is not a vector quantity. So the answer correct option is A, mass. Okay. Now, let us further see the next question. The next question says that the total linear momentum. Now, again, linear momentum, but this time they're talking about total. Total means the combination. Now, combination of what? Combination of gun and bullet. But when on firing. So, the question is the total linear momentum of a gun and bullet on firing is. So, options are A positive, B negative, C 0. We can't say. Okay, so let us see what are the let us see what is the question all about. What would happen if we're talking about the system of gun and bullet? We know that as soon as we fire, since they're asking us on firing, we know that as soon as we fire, this is the bullet which move in the forward direction. As a result, there will be a force in the backward direction, so this gun is going to move in the backward direction. Right? Before firing, क्या situation था? Both of them are at rest. So if both of them are at rest, then total momentum is going to be 0. We know that according to law of conservation of momentum, if total momentum before firing is 0, then total momentum after firing should also be 0. So वो 0 होगा अगर पहले तो वो बाद में भी 0 होगा. So our answer is 0. And that is the reason that the bullet moves forward and the gun moves backward. Okay. So since they're moving in the opposite direction, so they'll cancel out and the total will come out to be 0. So got me? Total momentum Q 0 because before firing it's 0. So according to law of conservation of momentum, after firing the total momentum 0 hona chahiye. Though they have mass, they have velocity, but both of these velocity are in opposite direction. So it is going to be, the total sum is going to be equal to 0. Okay. So the correct option is 0. There are so many MCQs right here where the answer is 0, right? Okay. Now moving on to the next question. Do action and reaction forces act in the same body? We've learned this concept. I told you during the session of Newton's third law of motion about action reaction. एक ऑब्जेक्ट एक्शन करता है तो दूसरा ऑब्जेक्ट रिएक्शन शो करता है. Let us see this by an example. So what's happening? The man is jumping here, right? So when he's jumping, he's applying a force here, right? When he applies a force here, he bounces back. So that means this object is also applying a force on the person. So both of these are in opposite direction and also acting on the opposite person or are not on the same body. This is acting here, but this is acting on the person. So the answer is no. Both action and reaction always act on the different body. And then one more question they ask here. Then why don't the action and reaction force cancel out each other if they are equal in magnitude? They don't cancel out each other if they are equal in magnitude because they always act on the different body. Forces only cancel out each other's effect when they act on the same body. If they don't act on the same body, they will not cancel out each other's effect. Okay, moving on to the next question. Do action and reaction forces produces the same magnitude of the acceleration? Now, action reaction forces are the one acting on one object and the other one acting on different object. So, if these forces are equal in magnitude, will they produce same acceleration? So, again, let us see an example. So, let us see this person is exerting a force on the jaw of the first person. Right? This was the action. So as a reaction, his feet, his jaw, his hand will also be hurt because there will be some reaction from his body. But as you'll see that since this person, let us consider this person is applying a force on this person, so he is moving in one particular direction with a large amount. But this body is not moving with that large amount. You might have seen that, right? The one who is applying the force might move to a larger distance, but the one who is applying a reaction on the first person may not move to the larger distance. So the reaction may not be till a larger distance which is seen on the first body. Why so? Because masses of both the objects are different. So the answer is, though action and reaction forces are equal in magnitude, we know that action reaction pair is always same in the magnitude, but these forces may not produce acceleration of equal magnitude. Why? Because each force acts on the different object which have different masses. So if they have different masses, then according to Newton's second law, acceleration is inversely proportional to mass. So a body which is lighter is going to accelerate till a larger distance, but a body which is heavier is only going to accelerate till a smaller distance. Is it clear? So acceleration depends upon the mass of the body. You should be very sure about this. It depends upon the mass of the body. Moving on to the next question. Why is it difficult to walk on a slippery road? You must have observed something like this, right? When you're moving on snow or when you're moving on a surface which is highly lubricant, right? So what happens, you find it's very, very difficult for yourself to walk. Now, why does that take place? See, this is because when you're walking, we have learned that in Newton's third law that whenever you walk, you try and push the ground in the backward direction. So in return, the ground gives you a forward direction, right? But when it is slippery, then the friction is very, very much less on that particular slippery road or slippery area. Friction is very important for you to move forward because we know that friction always acts in the opposite direction. So if you are applying a force in the backward direction, friction is going to apply a force in the forward direction, due to which you get a forward push. So अगर friction कम होगा, that means you are getting less forward push. If you are getting a less forward push, then you will not be able to walk easy, right? So it becomes very difficult on a slippery road because in a slippery road, the friction is very, very less and we cannot exert a backward action force on the slippery ground, which would produce a forward reaction force on our body for us to move the forward direction. Am I clear? So this is because of the less friction. Moving on to the next question, which is question number 8. So, bullet thrown with the hand can be stopped easily, but may kill a person when fired from a gun. Why? Right? This you might have observed also. Let us see why does this happen. See, this is because even if the bullet's mass is very small, it can kill a person. Right? That we have seen. Now there are two possibilities. If you throw it with the hand, the person who is standing right in front of you is going to catch it and will not die. Right? Because in both the cases, if it is fired from a gun, if you are throwing with your hand, both the cases the mass of the bullet to remain same, right? So even if the mass of the bullet remains the same, then also the velocity in both the cases are different. The one in which you are throwing with your hand, the velocity is very, very less. But the one when you're throwing with or when you're firing from a gun, the velocity is very, very high. Now, since the velocity is very high when it moves out from a gun, then the momentum produced is very high. And this high momentum produces a large force on the body, which kills the person. Whereas one which is thrown with the hand will have a very small velocity. So that will not have a momentum enough to kill the person. So that will not kill the person. So easy logic, both the ways mass same रहता है, but both the cases में if you'll see velocity different है. Higher the velocity, higher is the impact. Why the impact is higher? Because momentum is higher. Momentum is associated with force according to second law. So force would be higher. It will kill a person. Okay. So whenever beta, if you by reading the question also, if you don't know the answer, then there's a way when you can link the answer. So अगर वो kill करता है उससे और अगर आप hand से उसको throw करते हो, then what is the difference? The difference is only in the velocity, right? So on the basis of that, we are answering here. Okay. So I hope this is clear. It was an easy one. Moving on to the next question. So this is question number 9. Now, while playing football, the goalkeeper didn't get sufficient time to stop a fast moving ball shot towards him. Why did he get hurt his hand while doing so? Right? We see that when there's a game of football and the football players are kicking the ball towards the goalkeeper, sometimes the goalkeeper also gets hurt. Right? Let us see why. The reason is, see, when the ball approaches this goalkeeper, then we know that the speed of the ball is very, very high. Now, but when the goalkeeper catches it, that high velocity reduces to zero in a very, very short interval of time. Now, if that is reduced to zero in short interval of time, then according to Newton's second law, momentum increases, right? If momentum increases, then the force also increases. If the force increases, there'll be more impact on the person and there'll be more hurting. Similar question we've done, that why does a cricketer takes his hand backward while catching a fast moving ball? We've learned, right, that if he doesn't take his hand backward, then the high velocity reduces to zero in very less interval of time, due to which the momentum increases, force increases, impact is more, hurting is more. But if he takes his hand backwards, then the time to catch the ball increases, right? So the momentum decreases, force decreases, impact reduces, hurting is less. It's the same question we can link here with the football case also. So what is the logic? That suddenly the velocity reduces to zero, very short interval of time. So देखो बेटा, hurting है यहाँ पे, they are saying कि why is he hurt? Hurt तभी हो सकता है force ज़्यादा है. So ultimately you have to reach here कि force ज़्यादा है. Force ज़्यादा मतलब momentum ज़्यादा. Momentum ज़्यादा तो time duration कम होता है. This is how you link up everything, right? Because rate of change of momentum is directly proportional to force. So rate में मतलब क्या होता है? Time is in denominator. So that means force and time are inversely proportional to each other. Less the time, more is the force. That way you can link up and write up your answers. So I hope this is clear. This was a very easy thing also. So just link up all those that we have learned the previous concepts which is similar to this concept. Okay, and remember whatever questions I'm discussing today here is very, very important from the exam point of view. These are certain conceptual questions that are going to clear your concepts really in a easy and nicer manner. Next question. In a collision between a heavier and a lighter body. So there are two types of body. One is heavy and the other one is light. Lighter body is damaged more even when equal force is experienced by both. Why? We know that if there is a collision, right? Even if there is a collision में मतलब दोनों both the bodies are going to exert same force. Body 1 भी 2 पे exert करेगा, 2 भी A पे करेगा, but it is going to be force same, but it is going to be in the opposite direction. Even though the forces are same, lighter body is damaged more. Why? You can take an example of a truck and a motorcycle. So if they are colliding, what will happen? The motorcycle wala bhaiya, he will go and fall till a larger distance and he will immediately die. But the truck wala bhaiya, usko itna hurting nahi hoga, right? That is because of the heavy body and the lighter body. Now what is the concept? Let us see. See, lighter body is damaged more because according to Newton's third law, both are experiencing same force. But when we talk about second law, force तो constant हो गया, so mass is inversely proportional to acceleration. That means less the mass, more is the acceleration. So in lighter body, more acceleration will be produced. More the acceleration, then it will be more damaged. Okay, so what is the logic? So whenever they're talking about light body or heavy body, ना, so mass तो आ गया, so mass को you can relate with momentum or you can relate with acceleration. So in this case तो momentum नहीं कर बात करी हमने, we are talking about the acceleration. Okay, now moving on. So this you have to remember nicely. See, this is a big truck and this is a small car. Okay, or a little truck. Both are colliding are going to exert same force, right? Force is equals to mass into acceleration होता है. So I'm writing this in capital, मतलब इसका mass ज़्यादा है. I'm writing this in small, that means इसका mass छोटा है. तो अगर इसका mass छोटा है तो इसका acceleration ज़्यादा होगा. So I'm writing acceleration bigger way. So this is the acceleration of little truck. Whereas this का acceleration कम होगा. So this is the acceleration of big truck. So remember that way कि एक अगर कैपिटल एक बड़ा है तो एक छोटा है उसी के साथ में, मतलब मास ज्यादा है तो एक्सीलरेशन कम, मास कम है तो एक्सीलरेशन ज्यादा. दिस इज अ वेरी नाइस वे टू रिमेंबर थिंग्स. Okay, remember thing in this way. You can write down somewhere in your notes also because it is very important and a very easy manner to remember. Moving on to the next question. So if we have two bodies, A and B, when they interact with each other, see, whenever they're talking about interacting, that means they are colliding. They are in contact with each other. Okay. A exerts a force of 10 Newton on B towards east. Now the direction is mentioned also. That there is a body A which exerts a force of 10 Newtons on the body B. And the direction is towards east. Then what is the force exerted by the body B on A? So let us consider the situation that this is body A, right? Now this is body B. I've told you that they are interacting. That means they are in contact with each other or they are colliding with each other, right? So they both are interacting. Now they're mentioning that body A is applying a force on body B, right? So see A on B. So arrow from A towards B. How much the force is? 10 Newton. So 10 Newton का force apply करता है. Now the question is what? मतलब how much will be the force exerted by B on A? So by B on A, right? So how much force will this B exerts on A? So the arrow starts from B and towards A. This we have to find. Now we've seen that if there are two bodies and they are in collision with each other, they are colliding, and that means they're exerting force. And according to Newton's third law, that force is going to be equal to each other but opposite in direction. That means body B to A पे कितना लगाएगी again 10 Newton. But if this was towards east, this is going to apply towards west. Either हम direction की terms में लिखो. Or if this is 10 Newtons, this one is going to apply minus 10 Newton. That is what is our answer. So according to Newton's third law of motion, FAB is equals to minus of FBA. You can write this. Or you can also write FBA is equals to minus of FAB. Right? I hope you know now what is BA and AB. I repeat, BA means force of B on A. AB means force of A on B. So force will be minus 10 Newton because पहला वाला 10 था, तो second वाला would be with minus sign. Or if this is 10 Newton towards east, then this is going to be 10 Newtons towards west. So you write your answer in both the manners. Why I am emphasizing on this second part, that 10 Newton towards west? Because they are in the question mentioning the direction towards east. So we ought to answer in those terms in which our question is given. So depending upon the information of the question only you write. अगर ये नहीं दिया होता towards east, सिर्फ इतना दिया होता कि A exerts a force of 10 Newton on B. What is the force exerted by B on A? So you would have just simply written it as minus 10 Newton. But since I'm mentioning that towards east, then rather than doing this, you write down 10 Newton towards west. Okay. So these questions that we have discussed today are very, very important from your concepts point of view. So even though if you are not through with the lecture, I've tried and covered every type of the questions here. Just go through them, understand them nicely. Okay, so this is it for today's lecture. I hope you've understood everything thoroughly and nicely. So just keep practicing, and I'm going to see you in the next lecture. Thank you very much. Bye bye.